Great. So let's start with the webinar. So my name is Janesh Giwala. I am Industry Development Manager for Oil and Gas in Endress Hauser, Switzerland, mainly the headquarters. Good morning to a lot of you colleagues, and good afternoon to you to a lot of colleagues who are joining in from Europe. Thanks for joining in. There are a few things, administrative things, which I would like to share with you before we start with the webinar. Thing number one is you are all in mute mode, which you probably recognize because you see a red icon in front of you. This is to make sure that not a lot of noise is being circulated. Second thing is the fact that this presentation, which my colleague is going to do, he has already shared this presentation in the handout section. If you are not aware of where to find it, where you have the menu bar of the GoToWebinar, you will see one section which says handout, and this presentation is already put out over there. This presentation is quite intense, so I will request Haitui to go through the whole presentation in one shot. But anyways, if you figure out that you want to ask some question, make sure you put the slide number and also put down your question so that my speaker can handle this question at the end of it. Okay. Tui, can I have the next slide? So this webinar, which you hear today, or see, and also see me today, is the one from a series of webinars which we have organized, especially in these times when a lot of my colleagues are not able to visit you. And the main topic today is Promass Q. Promass Q, it's a Coriolis flow meter, and as you all know, Coriolis flow meter is a multi-variable flow meter. It's quite versatile. It can do density measurement, it can do direct mass measurement, it can also do viscosity measurement. But today we are mainly going to focus on density. We have done some special things to make sure this particular Coriolis flow meter is not disturbed by variation in the process conditions like viscosity, density, process temperature, process pressure, and also ambient temperature. Okay, and for that reason we have an excellent session where we have introduced our global product manager for this topic. Kui, can you share the next slide? So just a brief about Endress Hauser Group. It's a strong partner in oil and gas for many years. We are a strong family-owned company with a 2.6 billion euro turnover from last year. 14,300 employees last year globally, and it's increasing as well. 76% equity, so we have a solid base, financial base to survive some financial storms as well. And we do a continuous investment in a lot of future-oriented technologies. And one of the key things which Endress Hauser is proud of are the 8,000 odd plus patents which are there. And these are the patents which make which go into our products, and they make let's say valuable addition to the user. Okay, and Tui, can you give me the next slide? Today's speaker is Haitui Ingo, 15 years with Endress Hauser. He has been in the industry for that long as well, and you can see his pictures where you can find him next to some spherical tanks, also visiting plants. So he's quite hands-on guy, and he's going to share with us all the special things which we have done to make sure the Coriolis flow meter, the Promass Q, offers excellent density accuracy in tough conditions. Over to you, Haitui.
So thanks a lot, everyone, for joining this session. Today it's about 45 minutes in total. Thanks a lot, Janesh, for the introduction. And yeah, within the next about half an hour, I will explain to you why the Coriolis meter, the Promass Q, can measure excellent density independent of fluctuating process conditions for you. So this means you have a guaranteed accuracy over a wide range of fluid and process and ambient conditions. I will show you some concrete examples, some measurements to prove this statement here. So here we are looking now at the meter, which will help you to save money. On the left side, it's the Promass Q. This is, let's say, it's a flow meter really designed for harsh environment. It measures, as you can see here, down here, the mass flow at a very high accuracy of 0.1%. And at the same time, it measures density very accurate with plus minus 0.2 kilogram per cubic meter. On the right side, you see now the new option what you have. This is the Promass Q Premium Density. Again, it measures 0.1% mass flow accuracy, and at the same time, this meter, because if you have a cascade transfer, you want to have even better accuracy than 0.2. Here you see you get 0.1 kilogram per cubic meter density accuracy. The special thing about, let's say, this density meter is, even though we have this high accuracy of 0.1, we do not need an insulation. Typical density meters in the market need an insulation, need a temperature control cabinet, but because we developed this density meter out of a very robust flow meter, which has to work with ambient temperatures between minus 20 degrees up to 40, 50 degrees Celsius. This is why you don't need, for our Promass Q density, you don't need insulation or temperature control cabinet. It's a big difference to any other inline density meter in the market. Why you want to have a density meter? So a flow meter is very important. A mass flow meter is very important for you, but to calculate the volume, you have to measure also the density. Here's one article from TÜV NEL where they show some new calibration methods where they check the meter at elevated pressure and at the same time at elevated temperature. So pressure and temperature are elevated, and there are some there's errors which you have to compensate. If you don't do that, or if they just show here now an example, you can have a look on that link. If you have a traditional procedure, 0.15% error, you have a field production of 5,000 barrels per day. At that article, the price of per barrel was still very high, $120 US. Now it's less, but still, instead of $300,000, we talk about $50,000, which you can save with a proper density measurement. Before I start now with the let's say detailed graphs and measurings, I would like to know from you what is your key concern when choosing a new density meter. So if you can now use your Explorer to type in www.menti.com or use your smartphone, I would like to get feedback from the audience here. What are your key concerns? Why I'm asking this, I really want to make sure that I address your concerns in this presentation today. Mounting direction is important for you. So best practice to verifying the inline density meter, accuracy and repeatability. Accuracy is mentioned here. So you still can type it in. I will read this besides the presentation. I will address this. Somebody put here in the chat the cost of the device, of course. This is an important parameter for you. But we look at mounting direction, accuracy, and best practice for verifying. We will talk about this. So the Promass Q density meter is a good substitution of your straight inline density meters, which you can see here, an example down here. This straight inline meter is obsolete, so you cannot buy it anymore, and the industry is looking for a successor. And this is why, we look at this market and we offer now to you this high accurate density meter with 0.1 kilogram per cubic meter, or in use A, you're using this expression 0001 grams per cubic centimeter. This is the accuracy what you can get. To substitute an existing straight inline density meter, typically it's longer, as you can see there, and there we are offering for easy substitution for you a spool piece, which looks like this. And on the spool piece, depending on your accuracy requirements, you can have a pressure transmitter or temperature transmitter together with the chorus meter. As you can see here, if you just look at the Promass Q itself, it's very compact to other inline density meters or to other straight tube density meters. So it's very compact. You're looking for specific applications if you want to use a density meter, and here you typically look at quantities for capacity transfer, for transfer from volume to mass conversion, for offloading, allocation measurement, inventory control, product quality control, when you blend different fluids together, and also interface detection in a pipeline. So what is so different about the Promass Q density meter? It has really a superior density performance independent of fluctuating process conditions. We do additional calibration in our factory to have a very good temperature coefficient. We do additional pressure calibration in our factory to get a very accurate pressure coefficient. And also very interesting, which people don't know, is that we have integrated the API tables into the device. So what does it mean? You can get out of the device directly the reference density. Typically, if you have a straight tube device, an older device, you just get the raw density out of the device, and the flow computer is doing the compensation of pressure and temperature in the flow computer. We are doing the compensation of pressure, temperature, and more in our device, and we calculate the reference density according to API. So you can get directly out of the device the reference density. So in certain cases, you don't need a flow computer anymore, or a density computer. Also, for easy substitution of existing old density meters, we also are able to deliver the Promass Q with the time period signal, TPS, to connect to your existing flow computer. And again, the good thing, the news for you is you do not need an insulation or a temperature control cabinet. And just knowing that means a lot of cost savings for you already, because you know how much hassle it is to put insulation or even a temperature control cabinet into the oil field or chemical area. So now we look at accuracy, and here now we look at the specifications. So this is what it's written in the technical information, and this is the accuracy limits. So here you see 0.1, but interesting for you, it's written influence of process temperature corrected. So in other words, this is the remaining influence of temperature and pressure if you deviate from the reference temperature. So the reference temperature is 20 degrees Celsius or 1 bar. And now I would like to give you a concrete example. So here you see the graph now. The Promass Q premium density is the orange line here. The standard Promass Q is the blue line. Just for your reference, I put here other lines from another supplier here. What you can see here, at 20 degrees Celsius, the accuracy is 100 grams per cubic meter, or in other words, 0.1 kilogram per cubic meter. And if you have a fluid temperature of 80 degrees, the total, let's say, allowed error or the uncertainty what you have is then maximum 250 grams per cubic meter, or 0.25. So you have to take into consideration this residual effect. And if you look this up and compare also with other suppliers, with other inline density meter suppliers, you will see that the Promass Q has an outstanding performance with varying temperature. You see it's the smallest compared to the others. And how we do that in general, to how we are so good in making density measurements so accurate. So we do special compensations in our device. We do pressure compensation. We do internal temperature compensation. We compensate the ambient temperature because we have a case temperature RTD on our device. We measure the flow. And with the flow, you have additional centrifugal force, which we also compensate to get accurate density measurement. And here I would like to highlight this orientation. Our Promass Q, if you build it in for high precision density measurement, you have to tell the device, you commission that, you type it into the device, what kind of orientation has the device. Is it in flag position? Is it belly down? Is it belly up? Is it inclined? This you have to type into the device, because there we make additional compensation for the orientation. As far as we know, we are the only one in the market which offer you this additional compensation in a density meter. Also, which is patented by Endress Hauser, we also compensate for different viscosities. It's patented by Endress Hauser. Nobody else can do that or is allowed to do this. So with this, the meter design and the compensation technology, we are able to deliver far superior overall density measurement performance than any other density supplier in the market. Just to give you an idea, if you do not compensate, so if you don't do all these things here, pressure, temperature, case, flow, and so on, you can end up with an error of 3.35 kilogram per cubic meter. Keep in mind, 0.1 is what is on paper specified, but if you take in consideration all these things here and you do not compensate for that, you can end up with this error. And we heard from customers, maybe for some other reasons also, they might end up also in the past with 1, 2, 3 kilogram per cubic meter.
Before you move ahead, there's one question. Could you just cover the basic principle of operation, like tell them about the Coriolis flow meter itself, how it can measure density? That's one of the questions which came up.
Yeah. So we have a very nice video on YouTube. So everyone has YouTube nowadays, otherwise you wouldn't join this webinar, I think. Endress Coriolis. And then we jump to that. I think that's the simplest way to explain.
May include drinking water, the Coriolis principle. The French physicist Gaspard Gustave de Coriolis set out the physical basis for this measuring principle over 200 years ago. What is interesting is that the Coriolis principle allows the flow of mass to be directly measured. Let's take a closer look at how this measurement method works. A tube is located inside each Coriolis flow meter. An exciter causes this tube to oscillate constantly, here in an exaggerated example. If there is no flow, the measuring tube oscillates uniformly. Sensors are located at the inlet and outlet and register this basic oscillation precisely. As soon as the fluid starts to flow in the measuring tube, however, additional twisting is imposed on the oscillation as a result of the liquid's inertia. Now, due to the Coriolis effect, the inlet and outlet sections of the tube oscillate in different directions at the same time. The highly sensitive sensors pick up this change in the tube oscillation in terms of time and space. This is known as the phase shift and is a direct measure of how much liquid or gas is currently flowing through the pipe. The higher the flow velocity, and thus the total flow, the greater the deflection of the oscillating measuring tube. The application of the Coriolis measuring principle doesn't stop here. It can also be used to simultaneously determine the density of the flowing fluid. To do so, the sensors also register the oscillating frequency. In other words, how often the measuring tube moves back and forth in 1 second. From the animation, it's clear that a tube filled with water oscillates more frequently than a tube filled with honey, for example, which has a far higher density. Thus, the oscillating frequency is a direct measure of the fluid's density. Both the density and the flow are determined simultaneously but independently.
So now you have seen that. So the oscillation frequency, with that information, we can determine the density measurement for you. In the video, what you just have seen, you see the pipe is moving, but in reality, the movement of the pipe is in micrometer or even less. So in reality, you will not see that movement. It's just exaggerated in the video. So you can really say a cruise meter is no maintenance for you. And yeah, it will last 10, 20, 30 years yeah, without any issues for you. Now we look what I wanted to highlight here. So now we see, okay, nice that we implemented it, but what does it mean for you? If you do not implement this, and here we test now another supplier device, inline density meter. And now we do the test. We run tests in a climate chamber from us. Temperature chamber of us. Here you see the liquid temperature. So the pipeline temperature, and here you see the ambient temperature between 20 degree and maybe 40 degree. And the line temperature is from maybe 10 to 70, 80. So we ramp up the line temperature, and then you see we have now a bigger difference between ambient temperature and line temperature. And the blue line with this device, so from another supplier, you can see it measures very good if ambient temperature equals liquid temperature. Here at this point here. Or here, roughly. It's very close to each other. So this is why it's logical that I think most of the other density meter suppliers ask you to have an insulation or ask you to have a temperature control cabinet. Because you can see here, if you have 80 degree in the line and 20 degree outside, you can have additional error just because of this temperature difference of 1.6 kilogram per cubic meter. And this is massive because you want to have an accuracy of 0.1 or 0.2. Now, keep that picture in mind. We keep the scale, and now we look now in the next slide on the Promass Q. The same scale, the same test, increasing liquid temperature, ambient temperature, and look at the error bandwidth, what you get with the Promass Q. So I would say it's a considerable improvement. So we have a better compensation than at least for against that device, what we tested from another supplier. So it's very, very small deviation. And if we zoom in now, so now from 3, I changed to 0.3 here to see something what is happening. Then you can see that we mostly fulfill within 0.1. So I showed you a concrete example how well Promass Q compensates for temperature. But again, we also compensate for pressure, viscosity, and so on. What we also do in addition, we do the correction from flowing density to reference density for you. So you get the reference density. Typically, it's done on your side in a flow computer, but you can do the calculation to get the reference density also in the device itself, so we can output for you the reference density. Here's a typical installation, what you have maybe today. So here's a device, here's a time period signal with the raw density. So you just get the raw information of the density, not compensated yet. You do the compensation here with pressure, temperature in the flow computer, just with pressure and temperature, not viscosity, not with not with viscosity, not with orientation, just the two things here. Then you do, then you get a better, let's say, density value, and then you convert this also to the reference density. This is typically what you do today or in the past. Now with the Promass Q, you get directly out of the device also the time period signal. You connect it to your existing flow computer, but here you get already the compensated density signal out. So we do the compensation for you in the device, and because you want to keep your existing flow computer, you do still the correction from flowing density to reference density in your flow computer, but the compensation is done in the device itself. Here's another option for you, how you could integrate it into the field when you want to use, let's say, modern communication protocols. You can also connect via Modbus to the flow computer, so not time period signal. And there you can get also compensated density, pressure, temperature into your flow computer. In that case, the Promass Q really acts as a digital gateway converter for you, which also gather the information of temperature, pressure to the device and send it to your flow computer. If you have a greenfield installation, this might be the solution for you, because you just use the API tables which are included or built in the device. You get temperature, pressure, and then you get directly out of the device the reference density. And that you connect to directly to your DCS, your PLC, your SCADA system, whatever you use. But flow computer, just to calculate the reference density, is not necessary anymore. Here you see the example. So really, if you have a real interest to keep the same face-to-face flange, here you can order from Endress Hauser a solution including a spool piece, including temperature and pressure. Easy retrofit for you. Here are some examples of some builds which we sold to customers. So here is for pipeline to in Germany from Ingolstadt to Karlsruhe, Castrans Oil, the customer in Kazakhstan. Here we have some pictures from the field where they just installed substitute a straight tube device with Promass Q and a pressure device. And here you see another example from a major oil supplier, international oil supplier, located now in USA. Here the density ranges between 30 to 75 degree API. Before that installation of the Promass Q, the old densitometer were out of specs of 1 kilogram per cubic meter. After the installation, you're in the range of maybe plus minus 0.2 kilogram per cubic meter. So customer is happy, and we are proceeding to have good relationship with the customer. Then we get also often the question about, nice device, I like the accuracy, but I like the single tube device because it's more or less full bore and I can clean it very easy. That's true, you can clean it easy, but if you look at the true performance of a straight tube device, the accuracy is not comparable with a two-tube device like a cruise meter. Also, if you have a bent device like this, all the new modern density meters are not straight tube anymore, they are bended because you want to have better accuracy. But with that, you might think you have issues with cleaning. That's true. The bend, it's a little bit more difficult to clean, but it's not rocket science. Also, if you look now at our design here, so the Promass Q, we have very smooth transitions. So there you can pull through the wire, quite simple. Here is another design from other supplier where you have 1, 2, 3, 4 elbows, quite sharp, bended, and this might be more difficult to clean than if you have it this way like us. So don't just look at the outside of the device, you have to look inside the device, how the measuring tube looks like to judge if it's easy to clean for you or not. Here's one example, what we recommend. So you use some cleaning wipe connected to an insulated metal wire, and then you just pull it through the measuring tube. You pull it through 2, 3, 4 times until you don't see dirt anymore on the cleaning wipe, and this is how you clean the device. Why you want to clean the device from time to time, and this is back to your comment at the beginning, how you do verification. So the verification, what you typically do is to do air density check. So you take out the device out of the line, you clean it, and then you know the density of the air, of your surrounding air at your elevation, at your location, and then you compare it with the measurement of the density meter. This is how you do it, air density check. In our calibration rig, we have upgraded our production with a new calibration rig to determine this pressure coefficient, what I mentioned at the beginning, DCP 13, and we upgraded our DCP 8 to determine the temperature coefficient very accurately. And of course, when you get our device, you get an accredited report, because it's an accredited calibration rig where we prove to you in our calibration rig it achieved, the device what you get from us, it achieved better than 0.1 kilogram per cubic meter. It's nice that we have an accurate calibration rig in our factory, but of course we want to prove to you also in external companies that our meter is the best meter in the market. And here we sent the meter to HD Fitzgerald, UK. They tested in different fluids. Here you see dodecane, loop oil, Largo 8, 100, ethanol, dextrose. You see the different densities, 750, 1050, and you see the deviation here. And as you can see here, we are within the bandwidth of plus minus 0.1 kilogram per cubic meter, different densities. Then the same fluids, but now with the axis with viscosity. Of course, we stay again 0.1, but this shows just you can change the viscosity. We still do very good compensation in our device. Here's another test which we did at TÜV Nel. On this graph here, you see water. So now you might say, "Wow, there's too many colors here." I try to guide you through because it's quite impressive, the result here. Here you see the temperature. The fluid temperature in this case is equals the ambient temperature, so 10 degree, 20 and so on. And here you see the graphs, the arrow curves of our device for 5 bar, 55 bar, 95 bar. So now just take the green one. So with 95 bar pressure in the line at 80 degrees Celsius, ambient temperature equals fluid temperature in this case. We have an error close to 0. Here, 95 bar. If you look in our technical information, the error bandwidth at 95 bar, what we could have in our, would be still in our specification, would be here at about 550 grams. This is the error bandwidth, which theoretically would be allowed according to the information what we give in our TI. But however, in reality, as you can see here, we are very, very close, much better than it's written, what's written in the TI in this case. So this was for water, simple fluid. But now let's have a look on more difficult fluid. It's toluene. And here, as you can see here, at 95 bar, again, the green line, we are within our specifications, but yes, of course, we are a little bit more out. So we end up at maybe minus 250 grams or 0.25 kilogram per cubic meter. But excellent measuring results. If you put any other device with this complicated or difficult to handle liquid on this rig, it will perform worse than our Promass Q. Here's another example from Mexico where they did some tests for your reference. And yeah, here are some calculations. I will not go through this in detail in this presentation here, but for you, for the handout, depending on the flow rate, depending on the crude oil price, depending on your old installation, what the accuracy was there, you might have a payback in 2 days. Maybe if you look at ship loading, offloading, after 3 times offloading a ship, after 3 ship loads, or maybe after 1 month if the flow rate is smaller than in the example before. So the payback time is reasonable, between 2 days, 1 month, maybe 2 or 3 months, but it's reasonable for the investment of a high accurate density meter. Very nice is also that we get an independent test from a user association. So it's the WIB test. And they compared the Promass Q versus Solartron density meter type 7835. We are happy to hand out to you this report, but in this report they make real tests and make direct comparisons between Promass Q and the Solartron device. And I can say, of course, the Promass Q performed similar or better. And have a look on the report. We are happy to share with you a copy of this. Again, independent. There's association is with 20, 30 customers, users from the industry, which initiated this test here. Then about the question, okay, I like your density meter, but sometimes I have entrained gas in my process. Will it influence the measurement? Number one, yes, you shouldn't. Yes, it influences the measurement. And if you talk about cost transfer, high precision measurement, you shouldn't have entrained gas in there. Free bubbles, we and nobody can compensate this for you. Free bubbles means big bubbles, slug flow, and also after a few seconds, the air is gone. This is typically free bubbles. What we can compensate for you, and this is now what I mean Promass Q and our special technology, we can compensate for you suspended bubbles. Suspended bubbles, if you fill it in, you see the micro bubbles here, and even after a few minutes, you still have micro bubbles here. Free bubbles you can get out, quite simple with an air eliminator. Suspended bubbles, these are the headaches for you, or can be headaches for you, suspended bubbles. And this one, we can compensate for you, suspended bubbles. How we do that? We have a patented technology for you, multi-frequency technology. We vibrate the device at 2 frequencies at the same time. So high frequency, low frequency. With that multi-frequency, this means we can compensate for micro bubbles. So here's a YouTube video. I just can invite you to watch that. Very informative to understand how we can do that. And it's patented by Endress Hauser, this multi-frequency technology. We did here also a test to see what is happening if you have micro bubbles there. And this is the result. So down here you see the Promass Q doing quite well compensation with a gas volume fraction of 2.5%. Promass Q here, close to 0. And here's another coolest model without multi-frequency technology. And when you don't have it at 2.5%, you can end up of a flow error of 12%. So this test was focusing on the flow error, but also for the density measurement, we do the compensation there. So it will be also close to, I would say, the maximum error what you would get maybe is 0.5 kilogram per cubic meter. So we can compensate that very, very well if you have entrained gas with micro bubbles. And again, this is patented by Endress Hauser. Nobody else can offer this to you. So these are my last 2 slides. I hope you keep in mind that the premium density of the Promass Q has an accuracy of 0.1. It's under real field measuring performance. This is why I like the picture here with rain, snow, and sunshine here. This is why you don't need insulation or temperature control cabinet. It's relatively easy to clean for you, and we can do, let's say, quite simple, seamless integration into your existing systems. With that, I would like you, with that last slide, keep in mind with the Promass Q density, you get superior density performance independent of fluctuating process conditions. And you get accuracy guaranteed over a wide range of fluid, process, and ambient conditions. So thanks a lot for listening to me, and I would be happy now to answer some questions from the audience. Thanks a lot.
So Tui, thanks a lot for the presentation, Tui, quite on time. There were a few questions which will come through right away. The first one is around size variation of the flange. What are the different sizes available and stuff like that of the flange?
So here, the Promass Q density option is dedicated or targeted for the density market. And typically in a bypass, in a slipstream, in oil and gas chemical, it's a 1 inch. This is why we developed now this version of the Promass Q for 1 inch only. If you can accept 0.2 on paper, but with all the compensation, what I just mentioned to you, we do that also for the Promass Q. You also get excellent measurement with the Promass Q, but for 2, 3, 4 inch, but then the specification on paper is 0.2 kilogram per cubic meter, not like 0.1.
So the next question is around temperature compensation. As we all know, the Promass Q already has temperature element RTD embedded inside the near the sensor tubes. when does a customer need external compensation?
He would like to have external compensation if it's custody transfer. For sometimes, let's say, don't mix it up. Yeah. So because the external temperature, the authority, the Meteorological Institute, they might want to check the temperature itself. And as you know, if it's inbuilt, the device, the temperature, you cannot get access to it. You cannot put it in a water bath to check the temperature. This is why it's still very common to use an external temperature to do, because of checking reasons, meteorologic department.
How far?
If you don't bother with a external company to check your performance, then you can use the internal temperature measurement of our device.
The next question is around how far can the temperature and the pressure element be from the flow meter itself?
It should be as close as possible. So there are some guidance in the API, but it should be as close as possible. So I would say 0.5 meter, 1 meter. Because, you know, if you put it like 10 meter away, you can have a temperature difference of 0.1 degree or 0.2 degree.
Sure.
This is why I would put it as close as possible.
Yeah, that's why I think you showed the spool piece where both the pressure and temperature element are next to the Promass Q.
Yeah, yeah. So you shouldn't take it too far away, unless you can guarantee that you measure exact the same temperature at your measuring spot of the temperature compared to where the coils is installed. But yeah, usually you have to put it as close as possible to make sure that it's the same.
So the idea is don't go so far away. Yeah. That the temperature and pressure have changed from what the Promass Q saw and what your temperature and pressure elements see. One last question. So is this density measurement typically installed on a metering skid?
It depends on the market, and it depends also on the. I just jumped to that slide. It depends here on the flow rate. Of course, you customers have to do, let's say, your personal calculation. Do I really need a density meter, and does it pay back? And this depends on the flow rate. This depends on the metering technology what you have today. If you do manual measurement, of course, you have to calculate somehow also the working time of the person into that, and you might find out that for your application, inline density meter is the better choice on mid and long term. So metering skids can have it. Really depends on the application. For example, I know from Russia they use a lot of density meters, because in Russia the market is mass. But yeah, from the history point of view, they use a lot of volume meters, and now to convert from volume to the mass in Russia, they use a lot of density meters worldwide.
So there's one question around.
I cannot say generic you have to use it for metering skids. There are so many different types of metering skids to say that.
True.
So many
metering skid is a vast topic.
And yeah.
Excellent. There's one more question. This is related to at what interval do you expect somebody to do the calibration?
The calibration, so typically in you cannot achieve this high accuracy. So if you look at our calibration in our factory, the calibration rig is really certified two times better than the measuring accuracy, so 50 grams.
Yep.
And to achieve this accuracies in the field is close to impossible. So what you do typically, if you are concerned about the accuracy of your density meter, you send it to third-party calibration rigs, like I showed at TÜV Nel, and maybe at Fritz Gerald, maybe in USA to somebody else, and there they check against a fluid the measurement. This is how to do it. This is, let's say, the way, and customers, I heard from customers, they might do that once a year, maybe every half a year, but it's a huge cost for the customers to do that. So to, let's say, extend this intervals, this is why they do this more frequent air density check, maybe every month or every 2 months. But sending it to a third-party calibration rig to test it, it's really expensive, and they might do it once or twice a year. Maybe they also install a master meter concept somehow, whatever. Maybe they, what I saw also at customer sites, they might put also 2 density meter in line. So one is checking the other, and if they're drifting too much opposite direction, they start to send it to a third-party calibration rig.
Excellent. Tui, just the last question, because I think we are running out of time. The Promass Q transmitter can be remotely mounted together with pressure and temperature transmitter?
So we have a remote transmitter, so Promass 500. So you can have the display 5 meter, 10 meter, 15 meter away from your sensor, if this was the question.
Yeah, that's right. Yeah. Good.
So of course we have a remote transmitter.
I think there are lots more questions which need to be answered, but I think considering the time situation, we will call it a day. I would just like to add 3 more points. One thing is this webinars which we are doing, we are typically doing it twice a day. So make sure when you are registering for the webinar, you select the time which is convenient for you. You don't need to wake up in the middle of the night to watch this webinar. So make sure you select the right time which is convenient for you. The second thing is this webinar which you just saw, the recording of this webinar will be available on the same GoToWebinar platform. You will get a link for this as well. So if you have some query after watching the recording as well, please feel free to contact us. And last but not least, as I mentioned, this is the first webinar of the series of webinars which we are doing at this moment to reach our customers, our representatives, our partners. The next one is 2 days later, and the topic is Raman technology for LNG application. So do join in and appreciate your attention during this webinar. Thank you very much.
Thank you. Goodbye.
Thanks, Tui.
Have a nice day.